Have you ever improved your Wi-Fi and somehow made it worse? That's exactly what happened to me. In this video, I'll show you the real mistakes I made in my own home network. Mesh nodes in the wrong place. Too much Wi-Fi. Yes, you heard me right. And the wrong devices on wireless. And how I fixed them using my mesh router, a few switches, and parental controls. If your home has multiple floors and or multiple neighbors and or kids, work devices, and smart gear, you'll walk away knowing what to unplug, what to hardwire, and what to leave alone. What did I do with the kids again? Now, before I set the scene, I wanted to tell you that I planned this video nice and short, and then I thought of another thing, and another, and another, and soon it became a small monster. So, if you are interested in only a specific part of it, feel free to click the chapters below and jump ahead. Now, for that scene. My house is about 20 meters long by 10 meters wide and has 2 floors and a basement. My network looks like this. One ASUS AX mesh router, 1 mesh node, 3 switches. I used to have 2 more mesh nodes, but I removed them. That choice alone fixed more problems than any upgrade I ever made. Keep that in mind. Everything else builds on this. My first mistake was simple. Like a lot of you who believe the sales guys, I assumed more Wi-Fi automatically meant better Wi-Fi. So I added mesh nodes. And yes, coverage increased all the way to the back of my garden. But so did the problems. Here's what actually happened. More radios meant more competition, even though it was a new mesh network. Also, more noise in the air from the wireless signals bouncing around the house. And worse roaming decisions by my older phones and laptops. In case you didn't know, Wi-Fi doesn't radiate like a light bulb. It behaves more like a donut shape, strongest around the antenna and weaker than you'd expect directly above and below it. In a 3-floor house, that matters. More Wi-Fi is not better Wi-Fi. And what was the surprise? Removing hardware improved my network. That catches people off guard, and it shouldn't. This is where switches quietly save the day. Here's what I wire. The TV, my games consoles, the NAS, the printer, desktops, and some of my work equipment. And what stays wireless? Phones, tablets, laptops, some IoT devices selectively. Why? Well, obviously, wired devices do not compete for airtime. That leaves Wi-Fi calmer, faster, and more predictable for the things that actually need it. Honestly, streaming a video over Wi-Fi while my PC was backing up was truly unpleasant. The same stream on Ethernet, rock solid. Now for a mistake that doesn't make Wi-Fi slow. It brings the entire network to its knees. Ethernet loops. This happens more often than people are willing to admit. If you have 2 or 3 switches and decide to connect them together in a ring format, sounds like you're preparing for a break in the system, right? Wrong. Actually, that little extra cable that makes up the ring, that just broke the system. Suddenly, everything is going to crawl or stop entirely. The typical home switch is cheap and either gets overwhelmed or cannot understand what's happening. So it goes super slow or it just stops working. On the other hand, those €1,000 enterprise switches can stop loops using something called spanning tree. It needs configuration and you typically need to be some kind of network expert to configure it. If your switch doesn't understand loops, it has no way to stop one. Now, daisy chaining switches in series. Technically, you can. Realistically, though, 2 switches in series usually fine, but 3 are, I don't know, often okay. 4 or more, you're tempting fate. Long chains mean single points of failure, but also more latency, and then again, hard to troubleshoot. Let me explain what I mean by daisy chaining switches, as well as the single point of failure. Here we have 4 switches, and we want to connect them so that they are all on the network and other connections can happen to them. We would take a cable from switch number 1 and connect it to switch number 2. Then we'd do exactly the same thing. From 2 we'd go to 3, and from 3 we'd go to 4. So you now have all 4 switches on your network. Now, if something happens to switch number 2, we don't have a connection. These number 1 and number 3 are not connected. So therefore, any traffic that comes to 1 cannot get to 3 and 4. Obviously, 2 is unavailable. It's maybe died or has a power supply problem. And the same thing goes with any computers or devices connected to 3 and 4. They cannot communicate with number 1. So wherever your main router is, the traffic is lost. Okay, in this scenario, we have, again, 4 switches, but numbers 1 and 2, as you can see, I've added some antennas. So these are wireless switches or routers that are acting as a switch in this network scenario. So let's once again connect, let's say, the 4 to the 3 with a cable, and then the 3 will go to a 2 with another cable. So this would also be, again, the 100-meter cable, just to make it worst case scenario. And then 2 and 1 would need to connect in some way, but we're not going to have a cable because, let's say, they are very, very far apart, or they are in a place where a cable cannot be routed. So they would communicate with wireless. Now, the wireless communication is just set up in the configuration. So these basically would talk and connect wirelessly. So a PC connected to number 1 would wirelessly connect to the network and talk to the PC connected on number 4, for example. The problem over here is, although we're talking about nanoseconds, let me use a different color for that, nanoseconds of latency in this scenario for a cable. Again, nanoseconds of latency in this scenario. Over here, because it's wireless, because we don't know that we may not have a clear path, we're talking about millisecond latencies for this. This could be very close to each other, but it could also be very far, depending on what interference the wireless network over here has. The milliseconds will increase. If you're streaming something live and you are sitting over here on number 1, so you have a computer or a TV, let's say this is your TV, and you're streaming from your internet connection. This TV is physically connected here with a cable, great, but you're streaming and the original, let's say the source, is connected to number 4. So it needs to go through this path to get to the TV. So if you have a millisecond latency over here, delay over here, these don't give you much of a delay because we're talking nanoseconds, but anything that is something like a 20 to 30 millisecond delay, you will have buffering issues. So you will see that on the TV, your video will be choppy or not clear. Sometimes you see them in a blocky format. This could be due to the delay that's happening over here. Of course, you could have problems with the source. So if your source is on the internet, let's say a Netflix movie, and you're streaming directly from the internet, you will have you could have a ISP problem, which has got a delay in there or latency there. But if in this typical scenario, this for me would ring bells, and this would be the problem section of the network. Just because Ethernet allows it doesn't mean that it's the right call. Now, have you ever heard of a star topology? Well, in my opinion, for home use, that's a winning combination. One central switch, everything connects back to it with a single cable. So here's mine. I put my ASUS router switch combo in room 1 and with a cable connected the 20-port switch of floor 1 into it. I put my other 20-port switch on floor 2 and with one cable connected it to the ASUS as well. That means my ASUS is the center of the star, and I can connect a third switch if I had one. It's easier to understand and much easier to fix. Okay, let me explain the star setup in this format as well. So here is my ASUS, as in the other diagram, and I would connect my 20-port switch on the first floor to the ASUS. I would also connect this one on floor 2 to the ASUS, and let's say my third one would be a 10-port switch, and I would do that. It would be somewhere in the house, and maybe I have another 24-port switch at a different location. As you can see, this kind of looks like a star now, with the ASUS being in the middle of that star. And let me try a different color. The others switches are part of the star configuration. What's great about this is you do have a single point of failure, which is your ASUS in my diagram. But if you do lose the ASUS, obviously you would lose other things. For example, your internet connection, I presume, would be coming into here as well. This is off to the internet. And then this would cause other issues because I presume the ASUS would also be running your DHCP, your DNS, all those other kind of things. But if you, as these are not daisy chained, if you do lose this one, or this one, or this one, or this one, it doesn't affect the other parts of the network. Obviously, you would lose whatever is on this switch here or on this switch here, but because this one is only relying on the ASUS and this one is only relying on the ASUS and this one, etc., you don't have a single point of failure in a chain scenario. The only single point of failure is the ASUS, and as I explained before, this is kind of acceptable. You will always have a single point of failure on any kind of network. So this is my ideal setup. If you can do this at your home, this is exactly what I have at my home. You would definitely be helping not only your points of failure, the speed of the network, so there's less latency here, and it's a nicer setup to have for troubleshooting, because you can quickly identify where the problem is, if it's on the switch, if it's the ASUS, or if it's the internet, of course. Try drawing your network on paper. Follow where all the cables connect to and from, and draw it to see if you have a loop or are connecting in a star or daisy chain in your switches. Ever heard of beamforming? It sounds like Wi-Fi lasers. It isn't. Beamforming simply means that the router knows how to nudge more radio energy towards where it thinks your device is. That's it. It's encouragement. It's not mind control. It works best when there's a clear path, few competing radios, and devices aren't constantly moving. It works worst when mesh nodes overlap, when there are too many in a small area. The signals collide and devices bounce between floors. In my case, when I had more nodes, beamforming had too many choices, and it made the wrong ones. So what did I do? Easy, remove 2 of the 4 mesh devices. Less noise in the air, and the remaining 2 devices can now breathe easier. And I can see that in my everyday usage. Faster connections and fewer Wi-Fi drops. Beamforming improves a good layout, but it cannot rescue a bad one. Nowadays, but also going back a few years, already, when you buy a router, it has a possibility to do various things. It can be a router, of course, or an access point, or a range extender, or a media bridge, and finally, for the newer versions, the new models, a mesh node. Now, when you connect it to your network that already has a router, it's always best to set the newly added device to not be a router. You must not have 2 routers on a single home network. It makes no sense to have 2 masters on your network, especially if you don't know how to split what these masters do. I'm talking about things like DNS and DHCP and the other things that they can do. I deliberately set my second unit as an access point, not a router. Here's an easy way to think of it. Router is the brain. AP, or access point, is the arm. If you just connect a second router without configuring it, it can cause conflicting DHCP, DNS search issues, inconsistent controls, and so much more other things. So, only one device should be in charge. 2 bosses rarely make a happier home, trust me. Networks are no different. Here's where I stop talking and start showing. Let me go through my ASUS app and show you how I've configured that for my local home, the schedules that I have, some device rules that I have, and then I'm going to quickly flip through Google Family Link for parental controls and Microsoft Family Safety also for parental controls. Here's the distinction. Router controls manage network access, app controls manage device behavior. Both of them matter. And I cannot stress this more. It is not about punishment of the children. It is a discussion that you need to have with your kids. They need boundaries and they need to know why. The only thing these tools do is help you enforce them. This not only reduces arguments, but it gives the opportunity for your children to experience other aspects of their life. Maybe inside, maybe their books, maybe outside in the garden on a nice day. Here you can see that I've opened my ASUS app on my mobile device, and I'm going to go through what I have set up for some of my devices based on. I will now go to settings, and then from the menu over here, click on parental controls in the middle. And there I can either block all the devices, which I have not done since I've had this, but if you do want to, you can. Otherwise, I would specifically schedule a block for a certain device. So I would click on schedule block, and here you'll see a list of my devices which I already have a schedule for. Let's focus on the top one, the Xbox. So if I click on that one there, I currently have a setting of everyday, which is enabled, but I will change that because when the schools start again, I will go back to the original schedule, which is in the bottom there. The device will automatically block internet access for the Xbox. I will use the bottom schedule because the router will now automatically block access from Sunday to Thursday at 20:45. During the holiday periods, we have more leniency and we play it by ear as to what the children can and cannot have access to in the time. So for the moment, the maximum block time is every day from 11 to 7 in the morning. If I go back, there are other devices which are currently in gray, which means they are physically off. So if I take the PS4, this is the typical schedule we have during the school days, and this works well for my family and for my children. So if we go back to devices list here, I can at this point click on the little no entry sign on the left hand side. So if I want to block access to my Roomba, for example, I would click that little no entry sign. I will click OK. And there you see it becomes red. So now my Roomba vacuum cleaner does not have access to the internet because my ASUS is blocking it from getting any kind of access to the internet. I don't want to do this, so I'll just click the little red one again, and now it will remove it. So you can instantly block access to internet. Moving on, we're now opening up the Microsoft My Family, and I'm going to click on another child of mine's account to see what devices they have. And at the moment, this child has one Windows device connected to their account. And I can see some features here. So if there's an Xbox, if there's a mobile connected, I can see, for example, they've visited very early in the morning, netflix.com. But as I said, they are on vacation, so they do have access that way. When I go into the actual device, in this case, it's a Windows device, I can lock the device or set specific time limits. So if I switch on the time limit setting, I will get a little screen that says, what do you want to switch on? So from what time to what time do you want things to be on for? I'm not going to do that now. I'm going to just keep it on off so it doesn't block this device from the internet, but this is another way to do it. Another useful one would be the Google's Family Link blocking app or device control app. So in this case, again, it's linked to the account, so you would need to log into the device with the Google account. In this case, I have, for example, a tablet, which is using my child's device, my child's Gmail account. And here I can do multiple things. So if the device is lost somewhere in the house, you would click on play sound to play a sound, and then you can find it. I can see certain activity that they have, how many hours they've been using the device, and when. I can also, of course, edit the device name, like it says. I have certain lock screen settings, but I've currently disabled certain admin features like adding and removing users, apps from unknown sources, developer options, and editing date and time, which is important. If I click on controls, look at the specific account of this child, and I can see that certain Google Play options I have in there, approvals and restrictions, the YouTube access as well for what I can do, what they can do and can't do, and the Google Chrome web things, Google searching, if they have safe search enabled, all those kind of things here that you can look at. Specifically for this account, on the top you see the little red hat, and that is for this account linked to one of my kids' devices. If I look at the signed in devices, I can see that they're using two devices. One is a tablet and one is a mobile phone. If I click on the mobile phone, I have the same options as the tablet, which are currently disabled. So these are great things to have. If, for example, if this device gets stolen or is lost somehow, you can at the bottom hit the reset device and delete data, which is what I've needed to use at some point. Usually I use that when they get a new device and I need to wipe the old one. So those are good little quick things to do and settings to have. All right, let's bring this home. Best Wi-Fi can actually mean better Wi-Fi. Wire the things that don't move. Place your mesh nodes intentionally, not emotionally. Keep your wiring simple and loop free. And let one router run the show. The controls and the schedules, those belong at the very edge of your network, where they quietly keep the peace. You don't need to be a network engineer to have a stable home setup. You just need a layout that makes sense and hardware that isn't fighting itself. In closing, let me explain the truth that most people never hear. Most home network problems aren't caused by weak equipment. They're caused by unclear roles, too much overlap, or gear placed where it sort of fits. Fix the design first, then add hardware only if the design actually needs it. Less Wi-Fi used well beats a house full of competing radios. Cables don't make a home old-fashioned, they make it peaceful. And a single router in charge is not a limitation, it's how networks avoid personality crises. Once you start thinking in shapes instead of marketing slogans, donuts, paths, stars, the whole picture becomes easier. Simple wiring, simple roles, simple rules. That's what gives you a network you can trust. You don't need to master networking. You only need to understand your own network well enough to trust it, and then let it get on with its job. Thanks for sticking with me throughout this 3-video series. If you missed the first 2 episodes, the Wi-Fi Foundations and the Chaos Fix, you'll find both linked like my wingmen on the left and on the right of me. Watch those next, and your home network will feel like a different place. See you soon.